All right, class. Let us look at this topic, which I'm going to call the nitrogen cycle. Uh, but just to really put it into its context, sorry, I just need to mention there is another more common cycle that you are aware of, and that is the carbon cycle, in which in this case you say you've got the carbon dioxide, and uh, as you know, the carbon dioxide is done what is absorbed by the leaves of the plants through photosynthesis with the help of the sunlight to form the uh, uh, the the plants which we can take as foods, which will be eaten by the animals, and the animals are going to release the waste matter, which will form which is going to decompose or to form fossils through decomposition, and the animals like cows can release either methane or carbon dioxide directly to the atmosphere. Uh, but in general, if you're going to have fossils being produced, then over time they're going to be converted to things such as what coal and what and the petroleum uh, fuels, which are going to combust to form carbon dioxide as well. So this is a carbon cycle, yeah. So in this case, for the nitrogen cycle, it's a bit more complex, and so what I'm just going to do is that I'm just going to mention the highlights, but most of the details you're going to get from your notes. So in this case, you've got nitrogen, which makes up 78% of the air that you breathe. There's a reason for that. You may ask yourself, why can't the nitrogen be something like 20%, or maybe like there should be no nitrogen? The thing is, if there is no nitrogen, if for example the air was pure oxygen, then you can imagine how the combustion is going to be. Will be what? Will be uncontrolled, yeah. So it helps keep down the combustion of the oxygen, in which it can burn in a what in a more controlled manner, just as the presence of carbon dioxide in biogas, it helps tone down the combustion of methane. You know, methane burns in an explosive manner, but just the presence of the carbon dioxide in it, in the biogas, is going to burn in a controlled manner. So you and me, I believe you believe in God. So God had a reason for keeping the nitrogen percentage at 78, as opposed to a lot of oxygen, yeah, so that at least there will be life sustainable. Yeah? Okay, so let's get, so there is the nitrogen which is available in the atmosphere. It can be converted into forms which are usable by the plants. This is something you're going to call fixation. So there is the biological fixation, industrial fixation, or the lightning. So let me just mention these two. The industrial. There is this method of making industrial fertilizer directly by mixing hydrogen gas and also nitrogen gas. It's a bit of an inefficient process, but you're just going to get a small proportion of ammonia, yeah, and then ammonia, it can be mixed with nitric acid to form ammonium nitrate, yeah. So you know, ammonium nitrate is a fertilizer. So that one is a form in which it can be used by the plants directly. But then There is another method, which is the natural one, which has been going on for a very long time since the creation of the world, whereby there is lightning taking place, and this one has been shown scientifically that lightning can help uh, 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 it can help the oxygen which is available in the atmosphere plus the nitrogen with the help of okay, with the help of the rain, which is the water, to form nitrous acid. There was this mechanism which was I think I had a paper there which was proved. I think you can just see shortly. There was a 1971 paper in Nature. It's written the mechanism for the fixation of nitrogen by lightning. This is a 1971 paper. It was so significant that it was published in the prestigious Nature journal in 1971. So this mechanism has been proved that oxygen plus nitrogen in the presence of a very strong electrical discharge, in this case like which is simulating the lightning, you can be able to form and the water, it can form nitrous acid. As you know, the nitrous acid can be converted later into nitric acid. And now what you're going to see is that once you form something like the nitrous acid, in this case which is called the fixation method, then that is going to be absorbed by the plants, and then the rest of the processes here, you're going to look at them in the notes. These are biological processes in which the bacteria are going to convert them to ammonia, and then from ammonia to things such as the nitrates, and the process continue on. So there is the ammonification, nitrification, denitrification, back to the nitrogen in the atmosphere. So I think I think that's the much I'll talk about the nitrogen cycle. But where is this leading us to? This topic is directly related to the production of the something like ammonium nitrate, or other compounds which are going to call fertilizers, which are required by the plants for their growth. Yeah. So let's look briefly about fertilizers and their use to the plants. This is this topic which is in the syllabus. It's supposed to be covered under agriculture, but I think I'll just mention very briefly on things that are relevant to you as engineers. Okay, so let me delete what we've covered about nitrogen cycles, so that we can look a bit about. We can look at fertilizers. So it can be said to be a fertilizer. It's a compound which is either organic or inorganic. What you can say is, what is it, a natural or a synthetic compound which when it is going to be added to the soil, it's going to add what nutrients that are going to be relevant, that are going to be useful to the plants. It's going to add nutrients to the soil which are useful to the plants. Yeah. So in this case, we've mentioned about when we're talking as we're talking about the industrial fixation. In this case, we're talking about formation of something like ammonium nitrate. In that case, that will be an inorganic method of forming fertilizers. But you're going to see that that there is a much better fertilizer, which in this case you're going to call compost. Yeah, compost is provides a lot of nutrients to the plants, and it's not as dangerous as the inorganic fertilizers. You know, the inorganic fertilizers, if you're just going to put less, then the plant will not do well. If you're going to put too much, then also, excuse me, then also the plants are going to die. So you need to be careful with the inorganic fertilizers. But the organic fertilizers, like the compost, as I mentioned, you don't have to really worry about. You can be able to put a lot. You're talking about manure, yeah? Compost, manure, you can put a lot, and the plant will just take as much as it can take. Just like taking what? You taking glucose, yeah? I'm taking you back to the carbohydrates. If you're just going to take what? A lot of glucose, then a lot of it will be absorbed directly onto your body, and you are likely to get what? Diabetes, because that is refined sugar. In addition to that one, that glucose can also damage your teeth through cavity and the rest. But if you're going to take unrefined sugar like honey and the rest, you can take honey and even something like in the form of even medicine, and it's not going to cause a lot of it's not going to cause issues. You can take a lot of honey, but you cannot take honey the way you cannot take glucose the way you can take what? Honey. So the natural what? Fertilizers, you can put a lot of it in the soil, and it's not going to damage the plants the way the inorganic fertilizers are going to damage. So I hope this country hopefully even in the present or maybe in the future, we're going to be producing compost and manure sufficient for our agriculture, rather than be importing the inorganic fertilizers. Okay, because inorganic fertilizers are not as you mentioned, safe. And is it that safe or what? They can cause environmental damages and to the plants and to nature if you're going to put too much, and other issues. Okay, let's get back to the to fertilizers. Yeah. So these ones can be classified as you're talking about the compounds that nutrients that need to be added to the soil so that they can be absorbed by the plants. So there are things which are going to be called primary nutrients. There are secondary, and then there are micronutrients. Or these ones can be called trace. Okay. Now, now these nutrients are the ones which have got to be taken up by the plants in large quantities. Nitrogen, phosphorus, and potassium. Yeah. So these ones have to be absorbed by the plants in in large quantities, and then there are smaller one like sulfur and calcium, and then you'll have trace. The others are usually taken in small amount, very small amount. Okay, so this is what okay, let me say like what if you're going to have if you're going to be buying a fertilizer bag, you need to be knowing the quantities of the various nutrients that are being supplied by that fertilizer bag. Otherwise, you may supply some of these elements uh, what word can I use? Quantities which are going to be either excessive or deficient. Yeah. Like there are some soils that may contain these elements in high or in low quantities. So by doing soil analysis, you'll be able to know the type of fertilizer that you require for certain amount of soils. Okay. Let me mention something about these elements. You're going to see that when you're going to be buying a fertilizer bag, it's going to contain some numbers. You may see something like maybe 13-7- maybe 9. You may see another. You can see it's something like maybe 12- maybe 9.14, and then there can be a fourth number, maybe what? Maybe 7. I'm just trying to think of something like that one. Yeah. In this case, there is a standard way in which the nutrients that are going to be supplied to the plants to be grown are put in a standard a standard format. So that is your fertilizer bag, and some you're going to see these letters in a conspicuous manner. So the first letter refers to the concentration or to the percentage of nitrogen. It's not indicated, but it refers to the concentration of nitrogen. Okay. Okay. So the second letter refers to the concentration of the element phosphorus, and the third one refers to the element potassium. Yeah. Now, when it's going to have a fourth letter, if it's not indicated, you must assume that the fourth letter refers to the concentration of sulfur. It refers to sulfur, but occasionally you can find maybe 12, 9, 14, and then 7, and then you see the word in bracket calcium. It's telling you that the fourth element which is being supplied is calcium as opposed to sulfur. But if it's not indicated, then you are going to assume it is sulfur. So the fourth number refers to the concentration or to the percentage of sulfur. Now the fertilizer bag that contains all these elements, like particularly the three ones, the nitrogen, phosphorus, and the potassium, is said to be a complete fertilizer. But occasionally you may just want a fertilizer, especially in some soils that may be rich in potassium or it may be rich in phosphorus. You may just want to add a small amount of nitrogen. So you may find a bag written just like 1300. In this case, it's only supplying nitrogen, and there is no phosphorus, there is no potassium in it. So in this case, if for example I have something like a 25 kilogram bag, and then it has the numbers like in this case 1379, how can you be able to know the amount of the elements in each? What I'm going to say is that this number they refer to percentage, yeah. They refer to what? Percentage. So if you want to know the percentage of the nitrogen, this will be 13 over 100 times 25. Yeah. So it will be 0.13 times 25. You are going to find that one, whatever the kilogram. The other one will be 0.07. So this one will be the weight for the nitrogen. The one for the phosphorus will be 0.07 times 25. You're going to find that weight in kilograms of phosphorus. Then the last one, it will be what? 0.09 times 25 kilograms of potassium. Okay. Have you noticed something? That if you're just going to get these weights, you'll see that their weights, the total amount of the weights that you're going to get, is not going to add up to the 100%. Yeah. So the weights may come to probably 25 or maybe 30% of the 25 kilograms. The rest of the weight is something called a filler material. For example, okay, let me give an example. Okay, let me see whether I've got, okay. Here I've got something like, and once again, I'm not advertising any compound here. I mean, I'm not advertising any product here. So I may just try to show you. Here is a medicine, yeah? It's in capsule form, yeah? You're just going to take a big capsule like this one, but the actual ingredient could be something like 10 milligrams. But you're taking something like 2 or 3 grams or maybe 5 grams sample. So the thing is, this medicine is just, they've added an inert filler material to be able to make it way in which you can actually hold it or maybe you can swallow well. But the active ingredients could be in very small quantities. What I'm saying is this, similarly to here, the active ingredients in a fertilizer bag could just be adding to probably 25% of the total weight of the fertilizer bag. The rest is an inert filler material to be able to make those ions or those nutrients in a form which can be dispersed. For example, you want them to be in a what? In a either in powder or maybe like in pellet form or whatever, and form in which it can easily be administered with a mechanical spread and the rest and all those kind of things. So there are certain filler materials, the properties of the filler materials to be able to customize it for certain fertilizers. Yeah, I think so. For your notes, you'll need to check the various nutrients like nitrogen. what does it do to the soil? I mean, what does it do to the plant and its absence? What does it do to the plant? I'm afraid this may be something like in agriculture, but it may be examinable. Something like the nitrogen, phosphorus, potassium, and also sulfur, what they do to the plants and their absence and the rest. And also other things you need to know, which are also in the syllabus, are the quality of the fertilizer. Yeah, so you need to may know some other elements like the nutrient content and moisture content, because sometimes just like with the sugar, yeah, if the sugar is going to have a lot of moisture content, then it may not be of good quality as one which doesn't have sugar content, moisture content and the rest. So there are all those things that you need to look at: bulk density and the rest, moisture content, as I mentioned, particle strength and the rest. Yeah. So you need to look at those things. I'm just mentioning these things because I believe the notes are self-explanatory, but I just put these things to be able to help you go through the soft copy of the notes effectively. Yeah. So this short session was about what, the nitrogen cycle and the fertilizers. So I really hope you've really enjoyed this small video presentation on these two topics, and they will help you understand the lecture notes as they are presented. So thank you very much. We'll continue looking at other topics shortly. Okay, I hope you're enjoying the course. Yeah, you're looking at things which are relevant. I'm afraid these topics, especially these two which you've talked of now, they are more relevant to the students doing biosystems, environmental and biosystems. But whatever has been put on the course, we'll just teach them. Hard and soft water is applicable to what? Mechanical, and also petroleum, and also civil as well. Yeah. But these two topics, fertilizers and the nitrogen cycle, they are. What I'm saying is that the biosystems and the environmental will be using these topics probably for the rest of their lives. But as for civil, mechanical, and petroleum, not really. But good to know to be a well-rounded engineering student. So I really hope you've really enjoyed these things, and you're going to see that these are topics which you're going to use in one or another one for the rest of your life. So thank you very much. We'll continue to look at other topics shortly. Okay.